explaining two DSA problem, okay, which I got from today's assignment. So I'll walk you through the problem statement, code, solution. I will show the solutions live, okay, and discuss time and space complexity of that two questions, okay. So let's get started. So let me show you the first question, okay, that is the odd subset count, okay. So this is the question, odd subset count, okay. um, so in this question, basically, uh, the problem statement is given that an integer array, okay, we need to count all subset where the sum of the element is odd. Like for input, the first line contain the n size of an array, okay. The second line contains the n space separated integers, okay. Like this, like suppose I give you an example. Like suppose we have the array 1 2 3, okay, sorry, 1 comma 2 comma 3, okay. So the subsets of this array will be 1 2 3, okay, then 1 2, then 1 3, then 2 3, then 1 2 3, okay. So out of these, the subsets which is odd sums are, okay, I mean want to say that out of these subsets, the subset which odd sums are 1 3 and 1 2, okay, 1 3 and 1 2. So the answer is 4. Sorry, 1 3, 1 2 and 2 3 also, okay. uh, because if 1 is odd, 3 is also odd, 2 plus 1 3, which is also odd, 3 plus 2 5, which is also odd. If we going to sum of this and this, then it will be an even digit, okay. So that will not be considered. We only want to print the count of the subset, which subset will be odd, okay. So the output will be 4, okay. So this is our question. And I want to tell you the constraints also. Like constraints are the small n goes from 1 to 20 and array elements range from -20 to 20, which makes the backtracking solution feasible, okay. So now let me write the code, okay. Let take n is equals to array dot length. First let's declare an array. Let array is equals to, let it first be empty, okay. After that I will just going to initialize with some array and then show you the output, okay. At first let it be empty. So let n is equal to array dot length, okay, and we take count as 0. Now we're going to call one function. We're going to declare one function, okay. Put this name as backtrack index comma sum. We're going to take so we define a backtracking function, okay, that takes the current index and sum so far, okay. At each step we can either include the current element or skip it, okay. So just implement the function. If index is equals to 0, sorry, not 0, is equals to n, then uh, if the statement is, if a condition is true, then we move to next if condition. Under that, this if, okay, in this we write sum modulo 2 should be not equals to 0, okay, count plus plus, okay, and then we return. Now calling the backtrack function again, index plus 1 comma sum plus array of index track, Okay, backtrack. uh, Index plus 1 comma sum. Okay, so uh, we just define a backtracking function, okay, that takes the current index and the sum so far, okay, and each step we can either include or include the current element or skip it. Okay, now we finally start the recursion and print the count. Okay, so we are going to start a recursion and then print a count, calling the function backtrack. Yeah, 0 comma 0 and console.log count. Yeah, let's initialize the array with 1 comma 2 comma 3. So I just discussed earlier like what is the output of this 1 2 3 array. It will be 4. Okay, so let's just first run this command. Just check whether it's some getting error or not, or is it fine. Node example. Yeah, see, we are getting an output as 4. Okay, so now let's just discuss the time complexity and space complexity. So the time complexity, since we explore each element with two choices, include or skip. Okay, so we have the two n subsets. Okay, so the time complexity is big O of 2n. Okay, and the space complexity comes from the recursion stack, which goes at most n level deep. So the space complexity is O of n. Yeah, now let's just discuss about the second question. Okay, so this is second question, combination. Okay, combination of n k numbers. Okay, so in this question, uh, it is all about generating all combination of k numbers from 1 to n. The goal is to print all combinations in a sorted order. For example, if n is equals to 4 uh, and k is equals to 2, the combinations are 1 to, okay, like see, n is equals to 4 and k is equals to 2, the combinations are 1 to, you can see the outputs over here, 1 to 1 3 1 4 2 3 2 4 and 3 4. Okay, so let's just write the code and explain you with live code. Okay, so uh, we are going to create one generate combination function. Okay, and then take n and k as a parameter. Inside this I will use a helper function backtrack for recursion. Okay, so let me just write it quickly. First I will write code function generate combination. Okay, in this I'm going to use two parameter n comma k. Then I'm going to use take one array that will store all the combinations. Okay, so let's take one empty array which are going to store all the combinations. Okay, now inside this I'm going to write one more function. Okay, helper function, basically that will be a backtrack. Okay, function track. Okay, which will take parameter as and start and combo suppose. Yeah, fine. Now now we have taken a backtrack function has alpha function which take two parameters starts, okay, and which tells start which tells us which number to consider next, and combo, uh, the current combination which been built, okay. So if sorry, if combo dot length is equals to k, then result dot push dot combo, and we're going to simply return it. Yeah. Now we comes to the loop where we try all numbers from start to n. For each number, we add it to a combination and which recurs to explore the further numbers. Okay, and then remove it to backtrack for the next iteration. So let's just write code after this if condition for let I is equals to start, I should be less than equals to less than equals to n and I plus plus. Now we're going to write combo dot push I, okay. We choose I, okay. Now backtrack I plus 1 comma combo, okay, which we're going to explore further, and then combo dot push, sorry, not push, pop, yeah. So finally we start recursion, okay. We start recursion with 1 and an empty array, then return the result. Now we are going to backtrack 1 comma this and return result, okay. Sorry, I mistakenly write the wrong one. And return and return, yeah. Now we would write now we are going to write example, okay. So let n is equals to 4, let k is equals to 2. Now let combo is equals to, we call the function g n r t, yeah, n comma k, and we're going to console this combo, console.log combo. So we got the output as 1 2 1 3 1 4 2 3 2 4 and 3 4. So the backtracking function builds combination recursively, okay. Then we start ensure that we don't pick the same number uh, twice, okay, or go backward. Then combo dot push add a number recursion, yeah. So combo dot push adds a number recursion, explore further combo dot pop, okay, and combo dot pop undoes it to the next option, okay. And the base case here is the when combo dot length is equals to k, we store it, okay, and the output of an array is easy to visualize and print. So let's just discuss about time complexity of this question. The time complexity is the O of big O of, like, time complexity of is will be big O of, okay, uh, C n into, sorry, n comma k into k, okay, because there are combination of combination, okay, which C n comma k, which combination, and each combination take the O big O of k to store, okay. So the space complexity is O of k for the recursion stack and current combination array. So I hope you understand it. Thank you.